of elements. The key to answering this kind of question correctly every time, and in fact to just always getting things with molar mass correct, is realize that molar mass is essentially an equivalency. So you can use it as a conversion factor, okay? So what that tells you is if you've got the molar mass of something in grams per mole, let's use our trusty periodic table. Aluminium has the molar mass of 26.982 grams per mole. You often see it written like this, okay? Rewrite it if it helps you. What that means is 1 mole of aluminium weighs exactly 26.982 grams. That is my conversion factor to go between amount in moles and mass in grams, or vice versa. If I always go back to that equivalency, then I can always take this and write a unit conversion factor whichever way up I need it to go in order to cancel out my given units and end up with the units that I desire. So remember, whenever you're doing a unit conversion, you have given units, you can take an equivalency and turn it into a fraction with the given units on the bottom, so they get cancelled out, and the desired units on the top. Therefore, when you perform that operation, you're going to end up with your desired units, which is what we all want, really, isn't it? Okay, so let me just catch up with some lines here so you know what I'm talking about. Right, so that's a unit conversion factor from our equivalency. So given units will cancel out, give us our desired units. So in this case, we've been given the number of moles and we're asked for the mass in grams. So you can make a plan, right? Moles to the mass in grams. So technically moles, I should say the amount, and the unit is moles, right? Like that. So my conversion factor to get from amount in moles to mass in grams is my molar mass. So I would just write out my equivalency. In this case, 1 mole of aluminium equals 26.982 grams. So that is how I'm going to get from point A to point B. So here I will have a unit conversion factor. So my amount is 0.010 moles. Okay, where the arrow is where I'm going to put in my equivalency into a unit conversion factor. So don't even worry about the numbers. I know I want moles on the bottom and grams on the top. Okay, then go back to that equivalency. 1 mole of aluminium is going to be 26.982 grams. Okay, so now I can be really confident that my moles of aluminium are going to cancel. If you want, you can actually, it is best practice to actually write moles of what, because you may, well, hopefully you will stick along for the ride and start doing stoichiometry calculations at some point where you have to convert moles of one thing to moles of another thing. So it helps to keep track of moles of what, as I say. Okay, so we have 0.01 moles times 26.982 divided by 1, which should give me a mass in grams of 0.2692, of course. We are asked for 2 significant digits. Okay, so that would be here. Ooh, 9 is going to round up, so it's going to be 0.27 grams to 2 significant digits. Okay, so dimensional analysis is your friend. Look at that unit of moles of aluminium cancelling out, leaving me with my desired unit of mass in grams. Okay, so let's take a look at another one. Hopefully we'll go the other way from mass to moles. Okay, that's moles to mass. So I just want to rinse and repeat a few times. Moles. All right, let's try a couple more. Moles. Maybe we only go from moles to mass in grams, okay? All right, so we got 0.0400 moles of tin. So find tin in the periodic table. It's SN here, stannum, and yes, I can actually read that. So I'm going to write that as an equivalency. 1 mole of tin weighs exactly 118.71 grams. Well, that's nice, isn't it? So if I have 0.04 moles of tin, I want to convert it to mass in grams. So I'm going from my amount of tin in moles, okay, to my mass in grams. So my equivalency is going to be that the molar mass of tin written out just like that. So I can go from 0.0400 moles of tin, let's be specific. So I know that 1 mole of tin weighs exactly 118.71. So 1 mole of tin goes on the bottom. Oh, 118.71 grams goes on the top. So I should be expecting my answer in grams. Okay, dimensional analysis is your friend. Hope that's the right color. Yep. Okay, so the moles of tin is going to cancel out, yeah? What do we get here? 0.04 times 118.71 equals 4.7484 grams. We were asked for 3 significant digits. So 8 is 5 or above, so that's going to be 4.75 grams. Okay. Practice this one a lot. This is basically like the most fundamental conversion you're going to do in chemistry, going between moles and mass and vice versa. Okay, so it's really important that you get lots of practice. Ha ha ha. We do go back from grams to moles. Perfect. I was hoping we would. Okay, so gold. Let's pick orange, I guess. So let's find gold on the periodic table. Au from aurum. Well, that was some lucky crop in there on my periodic table. So we can write out an equivalency, okay? 1 mole of gold weighs exactly 196.967 grams. Take that molar mass and turn it into equivalency and make it work for you. Okay, so we want to convert between mass in grams to the number of moles, so the amount in moles. That is what we are doing. Let's make that box bigger. And our way of converting from one to the other is using the molar mass, okay? So my mass in grams is 6.4. So it should be the grams that's cancelling out. So look what I'm going to do here, okay? And again, I'm not going to worry about numbers yet. I'm just going to put grams on the bottom, move over, and moles of gold on the top, okay? Do that first, and then sort out for every 1 mole of gold, it weighs 196.967 grams. Now, you've probably done moles before at some point, and you've been told, hey, if you want to convert moles to mass, you times by the molar mass, and if you want to convert mass to moles, you divide by the molar mass. That's exactly what we're doing here, but I don't like saying, hey, if this is this, do that, because that's just memorizing something which may get muddled up. But here we can clearly see the grams is cancelling out and we end up with units of moles, which is what we desire. So 6.4 divided by 196.967 gives me 0.0. Number of moles is usually small, right? 3249272. Run out of calculator space. Moles. We're asked to 2 significant digits, which is going to be here. 4 is under 5, so boom, there we are. There's our answer. And I'm going to stop now. Okay, so get some practice with that. Lots and lots of practice.